Good afternoon, everyone. As I'm sure you know, my name is Lisa Schaefer. Thank you for joining us today for this training session on the amendments to the New Jersey Stormwater Management Rules. So in case you missed the announcement, we are recording this presentation and you're welcome to refer back to it once we post it online. Now, I'm going to ask that since we have so many people, that you please use the chat to post your questions, and we will do our best to catch them all. So the moderator will take care of those for me, and we'll try and catch up with the rest at the end. Again, I apologize in advance if we miss any because there are so many of you in attendance. Now, if you would prefer, you're welcome to email your questions to the email address that's found on the bottom of the slide, and I believe someone will be pasting that into the chat as well for your reference. So as you may have heard, amendments to the New Jersey Stormwater Management Rules, which are found in the New Jersey Administrative Code as Title VII, Chapter 8, and the Flood Hazard Area Control Act rules at 7:13, they were adopted and published in the New Jersey Register on July 17th of this year. The amendments address one of the major threats climate change presents, that is, increased volume and intensity of rainfall events and the attendant effect of additional runoff on stormwater management systems and flood elevations in riverine areas. Today's presentation will focus on the amendments to the stormwater management rules, as rule update presentations are now required training for those who review major development projects for a permittee under the Municipal Separate Storm Sewer or MS4 permit within 1 year of the adoption of said amendments. Okay, so today I will first provide you with a brief history leading up to the amendments and an overview of the studies that were also involved. Executive Order 100 was signed by Governor Murphy on January 27th of the year 2020. This required that the DEP shall, within 2 years of the date of this order and consistent with applicable law, adopt Protecting Against Climate Threats or PACT regulations. Furthermore, it required that the DEP integrate climate change considerations, such as sea level rise, into its regulatory and permitting programs, including but not limited to land use permitting, water supply, stormwater and wastewater permitting and planning, air quality, and solid waste and site remediation permitting. So subsequently, Admin Order 2020-01 was signed by then Commissioner McCabe to integrate climate change considerations and so forth into the DEP's regulatory and permitting programs. So in accordance with this executive order, the department conducted research and underwent several stakeholder meetings beginning in 2019, first as part of the PACT rules, and then again independently in October of 2022. The department released a New Jersey scientific report on climate change in 2020 and reports on rainfall studies in 2021. All of these were in preparation to address the impacts of climate change, which then led to the proposal on December 5th in the year 2022 and adoption on July 17th of this year of the Inland Flood Protection Rule. So the reasoning behind the rule amendments is based on the scientific studies showing the data used for the design of stormwater infrastructure is outdated. It no longer reflects what is happening in our state. So much so that in November of 2021, the Northeast Regional Climate Center, which is a partner with the National Oceanographic and Atmospheric Association, which I will abbreviate as NOAA, and the DEP released studies showing that the 2, 10, and 100-year storms have all experienced increases in rainfall depths since 1999. Furthermore, reasonable predictions based on this information show that this will only worsen over the coming decades. The areas with the darkest blue shading in this graphic are anticipated to have 100-year storms that will increase between 141 and 150% by the end of the century. So more rain means more runoff, which means larger discharges, and we will also see more flooding as a consequence. Additionally, global warming increases both the energy in the atmosphere and the potential for more intense storm events. The science predicts these storms will occur more frequently and at higher intensities than those of the 20th century, and I'll cover more of this shortly. Now, we've experienced quite a number of major flood events since the year 2000, and several of those are listed on this slide. So in many locations, stormwater runoff is often discharged off-site, and with the increasing intensity and rainfall depth, this will stress our infrastructure such as bridges, roadways, and stormwater management systems, and will create further problems down gradient of those discharge points. This in turn increases risks to the inhabitants and properties. Keep in mind, New Jersey is the most densely populated state, and most of the population centers are in the floodplain. So adding climate change on top of worsening flooding is just going to compound the issue and make things unsustainable. The NOAA's rainfall precipitation and intensity data published in Atlas 14, Volume 2, or on NOAA's Precipitation Frequency Data Server have been used in stormwater management designs. However, the precipitation and intensity were based on data collected from weather stations ending in 1999, meaning the design doesn't really reflect the precipitation we are experiencing today. Add to that runoff from older sites where there was no stormwater management, and the impacts will worsen, potentially wiping out infrastructure and putting people in danger. Climate change will continue to bring more intensive rain in the future. A stormwater best management practice, or BMP, has a long service life, and BMPs designed in accordance with outdated rainfall data will become insufficient to handle the increasing precipitation depths and intensities. Therefore, there's a need to project the increase of precipitation depths in anticipation of the effect of climate change and use the projected precipitation depths to design stormwater BMPs. So the adopted rule amendments are what is now required to address these impacts. So here's the agenda for the remainder of the presentation. I'll start with the two definitions that have been added to the stormwater management rules, and after that, I'll review the applicability to major development and discuss the legacy provisions, which are for those projects subject to the rules that were in effect prior to this rule adoption. I've included some examples under the applicability section of the rule adoption as well. There's also a change to the calculation methods allowed. And after that, there will be a bit longer discussion of the multipliers to be applied to modify the published NOAA rainfall data and how those multipliers are used in the calculations for groundwater recharge and stormwater runoff quantity control. I will also provide some examples, and I will briefly touch on the updates made to the BMP manual, the frequently asked questions, and the Municipal Stormwater Control Ordinance, which I will abbreviate as SCO when I cover the later slides. After this presentation, the team will provide answers to questions not covered in the chat, as well as to any additional questions asked as time permits. Okay, so as mentioned previously, the stormwater management rules at NJAC 7:8 are amended to address the role of climate change in the design of stormwater management BMPs. Listed on this slide is the layout for subchapter 1 in the rules. I've added bold text to show where the rules were amended, namely subsections 1.2 and 1.6, and the details of those changes will be coming up momentarily. Listed on this slide is the layout for subchapter 5 in the rules. Within this subchapter, the rule adoption amends only the bolded sections, namely 5.4, 5.6, and 5.7. The details of the changes are discussed after those for subchapter 1. So for those of you who like to keep things organized, all of the slides that follow that cover the stormwater management rules are a dark teal green and have a deep red tab on the top right. The slides for subchapter 1 will have a light green stripe on the left, and those for the calculations portion, which is subchapter 5, will have a deep red stripe. So the amendment adds two definitions regarding public transportation projects that are subject to the rules in effect prior to this rule adoption, depending on when the public transportation projects achieve a certain status. So for public roadway or railroad, that means a pathway for use by motor vehicles or trains that is intended for public use and is constructed by or on behalf of a public transportation entity. A public roadway or railroad does not include a roadway or railroad constructed as part of a private development, regardless of whether the roadway or railroad is ultimately to be dedicated to and/or maintained by a governmental entity. Public transportation entity means a federal, state, county, or municipal government, an independent state authority, or a statutorily authorized public-private partnership program pursuant to the public laws from 2018 at the citation noted here on the slide that performs a public roadway or railroad project that includes new construction, expansion, reconstruction, or improvement of a public roadway or railroad. Take note that a public transportation entity includes municipalities and counties that perform public roadway or railroad projects, but does not include the roadway within a private development, but dedicated to the municipalities or counties, or to be maintained by the municipalities or counties. So the applicability section of the rule indicates that a major development that doesn't fall under item B is subject to the rule amendments. For the purpose of this presentation, we would call this portion of the rule the legacy provision. All right, a major development project that does not meet those permits listed in section 1.6C, which are a flood hazard area, a freshwater wetlands, a CAFRA, a waterfront development, or a Highlands permit from the department, and has submitted an application for the approvals listed in the little Romanettes 1 through 5 at the bottom of the slide prior to July 17th will not be subject to this rule adoption. A complete application means that the application submitted to the municipality has all of the required documents specified in the municipality's ordinance, and the municipality's reviewer considers the application complete for the review of the stormwater management design. Take note that the application and all accompanying documents shall include the documents for stormwater management. Right? If the application submitted to the municipality for those approvals did not include the design documents for stormwater management, the legacy provision here will not be applicable. Item 2 on this slide establishes the time frame for projects subject to the rules in effect on March 1st of 2021. Again, providing it included all of the required materials I just discussed. And similarly, the same goes for item 3, except the rules are those in effect on March 2nd of 2021, and projects are also subject to the same conditions regarding the items that are submitted. Okay, now for item 4, which is the projects submitted to the department. So if a major development project needs a flood hazard area, a freshwater wetlands, a coastal area facilities review act, a waterfront development, or a Highlands permit, and those permit approvals need a stormwater management review component, is technically complete and has been submitted prior to July 17th, it is subject to either the rules in effect on March 1st of 2021 or to the rules in effect from March 2nd of 2021 through July 16th of this year, depending on when it was submitted, and provided everything required by the department's rules for those permits, plus the application form, are submitted prior to July 17th of 2023. One other thing is technically complete means that each item included in an application provides sufficient information for the department to declare the application complete for review, public comment, or public hearing. Okay, now I mentioned 1.6C. These are those department permits that I mentioned earlier, along with where they're found in the New Jersey statutes. Moving on, exemptions expire with the expiration, termination, or other loss of duration or effect of either of those qualifying local approval or department permits, whichever came first. The expiration of local approvals under B1 that I covered just a few slides ago shall be governed by local ordinance. So in the event that there are multiple qualifying department permits listed in 1.6C above, the expiration date is governed by that permit which expires last, provided that the permit is still in effect. But once the exemption expires, the major development shall be subject to all requirements of the rules as amended upon reapplication for that permit and all subsequent permits or local approvals under the municipal land use law. Okay, and there's one more citation for limits on these exemptions. So the aforementioned exemption is limited, this is really important, to the land area and the scope of the project addressed by the qualifying applications or subsequent approvals. The review agency will consider the impacts from any revision, including but not limited to the items listed here under 1 through 7, and may deem the exemption void if the revisions do not have a de minimis impact. An additional legacy provision exists for certain public roadway and railroad projects, and it's found under JAC 7:8 in 1.6F. Public transportation entities must demonstrate that the project has determined a preferred alternative or has reached an equivalent milestone prior to the rule adoption. The logic is that these projects have already undergone a significant level of planning and design such that revising the project now to meet the rules would be a waste of public funds. Okay, so next are a couple of examples to help clarify the applicability portion of the rule adoption. So for example 1, a non-residential major development submits an application for the department's Flood Hazard Area Control Act permit with a stormwater review component on August 1st of 2023, and it's deemed technically complete. The non-residential major development also submits an application to the township for a preliminary site plan approval on August 1st of 2023, but the township stormwater control ordinance is still in alignment with the rules in effect prior to July 17th. Okay, so what rules are applicable to this non-residential major development? The answer is that the department will review the stormwater component of the application under the stormwater management rules adopted on July 17th. Therefore, the non-residential major development shall design its stormwater management in accordance with the adopted rules. However, the township will review the stormwater management under its SCO pursuant to the prior rules. Since the design complying with the adopted rules is supposed to be more comprehensive and has higher capacity than the design under the prior rules, the design under the adopted rules should be able to pass the SCO pursuant to the prior rules. Okay, example 2. A non-residential major development submitted an application for the department's Flood Hazard Control Act permit with a stormwater review component on June 1st of 2023, and it was deemed technically complete. The non-residential major development will also submit an application to the township for a preliminary site plan approval later on December 1st of 2023. Now, the Township Stormwater Control Ordinance has been amended to be consistent with the rules adopted on July 17th by the time that the application was submitted to the township. So in this case, we're wondering which rules and SCO are applicable to this non-residential major development. Well, in this case, the department will review the stormwater component of the application under the stormwater management rules effective on July 16th, the prior rules. However, the non-residential major development will need to redesign its stormwater management to comply with the township's SCO, which has been modified pursuant to the adopted rules. Receipt of the department's approval on the stormwater management design does not necessarily secure the township's approval. The township's reviewer shall apply the township's SCO pursuant to the adopted rules when reviewing the stormwater management design for the non-residential major development. Okay, so next up is the amendments to Subchapter 5, which is the design and performance standards for stormwater management, and the slides will have this red stripe on the left to indicate that they all pertain to Subchapter 5 of the rules. Now, there are no changes to Subsection 1, which is scope, 5.2, which is stormwater management measures for major development, 5.3, which is the green infrastructure standards, 5.5, which is water quality, 5.8, which is maintenance, or 5.9, technical sources, but I'm going to handle the remainder of the subchapters out of order, starting with 5.7, the computational methods, as this impacts the remaining subsections. Now, right away, there is a change in the allowable computation methods, namely only the NRCS methodology is found in the adopted rules. So take note that the NRCS methodology must be used when calculating the water quality design storm. And throughout the remainder of this presentation, I'm going to do my best to give you page citations from the BMP manual. This particular information is included under item 13 on page 32 of chapter 5 in the BMP manual. Of course, you would refer to the National Engineering Handbook, which is available at the link provided on this slide. Again, you may no longer use the rational method nor the modified rational method to calculate stormwater runoff, whether for groundwater recharge, stormwater runoff quantity control, nor water quality. The rationales and the justifications to eliminate the rational method and modified rational method are addressed in the rule adoption notice that's available on the department's website. We will not repeat them here. Now, just a note, the rational method is still applicable for storm sewer or drainage system design pursuant to the residential site improvement standards, which are found in the New Jersey Administrative Code at Title 7, Subchapter 21, under subsection 7.2C5. All right, next up, we're going to cover the requirements for the precipitation depths used in calculations. Okay, the first set of precipitation depths to be used are those for the current 2, 10, and 100-year design storms. These will adjust the 1999 rainfall data to the year 2019. To the right is a reprint of Table 5-5 from the adopted rules. To denote the adjustment of rainfall data to 2019, the precipitation depth we will use for the 2-year storm for a project, say in Warren County, is 102% of the depth listed on the NOAA PDF server for the 2-year storm. For the 100-year storm in Warren County, the rainfall depth is adjusted to be 115% of the 100-year rainfall depth found on the NOAA PDF server. The first example that will be presented later today will illustrate the calculation of the current precipitation rainfall depth for a site. And if you're not familiar with using the NOAA PDF server, start on page 12 of the revised chapter 5 in the BMP manual using the publication date, it was published in July. Now, for a site that's in more than one county, you multiply the rainfall depth from the first area by the county's specific current precipitation adjustment factor for the design storm specified, meaning the 2, the 10, or 100 as applies, and then multiply that product by the percentage of the total site area lying in the first county. You then do this for the second area using the current precipitation adjustment factor for the second county for the same year design storm, and then multiply that product by the percentage of the total area located in the second county, and then you sum the two to get the current adjusted total rainfall depth for that design storm. And if you're looking at Chapter 5 in the BMP manual, example number B-1 is found on page 18, and it also depicts a site situated in 2 counties. One other thing, as an alternative, you can use the county 24-hour rainfall data from the NRCS and apply the current precipitation adjustment factor from Table 5-5 in the rules. The county-specific 24-hour rainfall frequency data that is published by the NRCS in the 2012 Engineering Field Handbook is also reprinted as Table 5-1 on page 15 of Chapter 5 in the BMP manual. Okay. There's a second multiplier required in the rule amendments. Applying the future precipitation change factors to the published NOAA rainfall data will allow us to look to the period from the year 2050 through 2099 to address the future impacts of climate change. To the right is a reprint of Table 5-6 from the rules. And what that means is that the precipitation depth we would use for the projected 2-year storm for a project in Warren County is 120% of the depth listed on the NOAA PDF server for the 2-year storm. For the projected 100-year storm in Warren County, the rainfall depth is adjusted to 137% of the 100-year rainfall depth found on the NOAA PDF server. So for a site in more than one county, it's the same method from the bottom of the previous slide, but of course it uses the future projected change factors. Once more, you multiply the rainfall depth from the first area by the county-specific future precipitation change factor for the design storm specified, and then multiply that product by the percentage of the total area lying in the first county. You do this for the second area using the future precipitation change factor for the second county for the same year design storm, and sum these products to get the future projected total rainfall depth for that design storm. And of course, I will have examples in just a little bit on adjusting rainfall data using these multipliers. Okay, now we have to also talk about time of concentration calculations, as the equation uses the rainfall depth resulting from the 2-year storm event. Now, although how to calculate the travel time of runoff in sheet flow is not explicitly stated in the rules, it's because the rules require using the current and projected 2, 10, and 100-year storm events in stormwater calculations. The 2-year storm event used in the calculation of the travel time of sheet flow shall also use the current and projected 2-year storm events respectively. Okay, so time of concentration for the current storms will use the current rainfall data. That is, multiply the NOAA rainfall depth for the 2-year storm by the current precipitation adjustment factor. However, for projected storms, be sure to multiply the rainfall depth for the 2-year storm by the future precipitation change factor. And if you're dealing with small areas, there really won't be much difference, but you will see this for larger drainage areas. One other thing I must mention is that the rainfall depth of the 2-year storm, or P sub 2, that's used in the calculation of the time of concentration for the water quality design storm is based upon using the projected 2-year storm event. That's a lot to remember, and you will find all of this information on page 25 of Chapter 5 in the BMP manual. Okay, So now that I've explained what the rules mean by a current or a projected design storm, let's go back to subchapter 5.4 in the rules. For groundwater recharge, the rules allow you the option pursuant to NJAC 7:8-5.4B1 under the first Romanette here on this slide to address the loss of recharge on an annual basis. And that's done through the use of the groundwater recharge spreadsheet. Nothing changed for this option. However, if you're going to infiltrate the difference between the pre and post-construction runoff volumes, you must do so as required under the second option shown here, using the projected 2-year design storm. And remember, the projected 2-year storm uses the future precipitation change factors found in Table 5-6 and the column for the 2-year storm. And of course, Chapter 6 of the B&P manual has been updated to match the rule adoption. Okay, now for the stormwater runoff quantity standards, which are found under subsection 5.6 of the rules. There are 3 options for which to select in order to demonstrate compliance with the requirement to control stormwater runoff quantity impacts. So under this bullet is the rule text for the first option to demonstrate compliance. The bold or yellow text is the portion of the rule that's been amended in the adopted rules. And if you recall, 5.7C is covered on slide 20 in this presentation, and 5.7D is on slide 21. The bolded text will be discussed after we look at the other options for demonstrating stormwater runoff quantity control compliance. Okay, so here's the rule text for the second option to demonstrate compliance with the runoff quantity standards. And again, as on the previous slide, the bold or yellow text is what is changed in the rule adoption. And lastly, this is the rule text for the third option to demonstrate compliance with the runoff quantity standards. And once more, what's bold and yellow is the portion of the rule that's been amended to the in the rule adoption. Okay. Well, regardless of which option is selected, the quantity control calculations required will have to include an analysis of the runoff volumes produced for both the current and the projected design storms. Okay, so that's 6 different sets of precipitation calculations. All right, now, if you recall, I covered time of concentration calculations back on slide 22, and that also comes into play here. So if you are using modeling software to design or review the accuracy of designs, you may want to create a model for the projected storms that is separate from those for the current storms because of the different rainfall depths used in your time of concentration calculations. And you may also find that page 84 of chapter 5 in the B&P manual, which is the updated summary of modeling guidance, will be helpful. All right, so I have 5 examples for you today. The first is applying the current precipitation adjustment factors to a site located in just one county. The second is for a site that's partly in one county and partly in another. The third is the comparison of the hydrographs from the pre and post-development conditions for the projected and current storms when impervious cover is reduced in the proposed design. The fourth shows how a design using a small-scale B&P will meet the groundwater recharge requirements. The fifth example is sizing an MTD using the NRCS methodology. So for the first example, we're going to apply the current precipitation adjustment factors to the rainfall data for a site that's located at Trenton Station 2 on the NOAA National Weather Service PFDS website. All right, so we go to the website found at the URL shown on the slide, and in the data description section from the data type drop-down menu, make sure that precipitation depth rather than precipitation intensity is selected as shown on the left here. Similarly, for the time series type, Ensure partial duration has been selected from that drop-down menu. Next, in step B, under the Select Location option, manually enter the location using one of the options offered on the screen, or use the map to locate the site, of course, making sure to zoom in. In this case, we're looking for Trenton Station 2. Next, you'll still be on the same web page, but you're going to scroll down to the Point Precipitation Frequency, or PF Estimates section. You're going to left click on the PF Tabular option if it's not the one that's on top. The others should have the dark blue shading. Okay, the data we need is found in the row labeled 24-hour. The values in the columns that we need are labeled 2, 10, and 100 year, as you can expect, and they correspond to the rainfall depths generated by our 2, 10, and 100 year design storms, respectively, for this weather station location, and they're shown with the red boxes in the top graphic. Okay, next, you go to Table 5-5 in the rules and look at the row for Mercer County. And to obtain the current precipitation depth for the 2-year design storm, you're going to multiply the NOAA precipitation depth for the 2-year design storm by the 2-year current precipitation adjustment factor. And then you repeat that process for the 10 and 100-year design storms using the respective adjustment factor. And those results are all shown in the column furthest to the right in the table at the bottom of the slide. And once again, if you're not familiar with using the NOAA PDF server, start on page 12 of the revised BMP manual in Chapter 5, which was published in July, for more details. For the next example, when a site is situated in 2 counties, the method is to obtain the current adjusted rainfall depths for each of the 2 counties and then weight average them based on the area of the site in its respective county. So here the site is located on the county line shared by Middlesex and Mercer counties. 1/3 of the site is in Middlesex and the remaining 2/3 is in Mercer County. In step A, we obtain the NOAA data and the current precipitation change factors and calculate the rainfall depths for each of the design storms for each of the counties. Next, as shown in the second table, we multiply the percentage of the project area within each county with the current precipitation for the respective county from step A, and then we're going to just sum the results for each of the design storms, and the final current precipitation depths are in the bottom row of the lower table. This example provides a scenario showing non-compliance with the requirements when the proposed development reduces the regulated motor vehicle impervious surface and increases the slope of this surface. So often for redevelopment projects, a designer may choose the option, the first option at NJAC 7:8-5.6b to demonstrate compliance for quantity control that for stormwater leaving the site, the post-construction runoff hydrographs for the current and projected 2, 10, and 100-year storm events as defined and determined pursuant to 5.7c and d respectively do not exceed at any point in time the pre-construction runoff hydrographs for the same storm events. Okay, so for a site located in Trenton, Mercer County, an approximately 2-acre paved parking lot is to be redeveloped as an office complex consisting of a new building, a parking lot, and landscaping. The existing lot has a slope of 1%. The redeveloped site will be regraded to a 5% slope for better drainage. The landscaped area will not receive runoff from the impervious surfaces, and HSG-C soils are present. So here you can see the layout of the the site for the existing and the proposed conditions. So next, let's look at the projected 100-year design storm. Okay, a summary of the results from the modeling software is shown in the table. To correctly calculate the time of concentration, first P sub 2 was calculated by multiplying the NOAA PFDS rainfall depth for the 2-year storm, right, 3.33 inches, with the future precipitation change factor of 1.16, giving us P2 is equal to 3.86 inches. Here in the table, of course, is the summary information. And, it looks like the results for the post-construction condition are less than that for the pre-construction values. Well, next, the modeling software is used to produce the hydrographs with the peak flow rates and the time intervals exported as data for input into a spreadsheet to create a chart. Now, although not shown here at first glance, the hydrographs seem to show compliance, meaning the post-construction hydrograph looks like it's under that for the pre-construction condition. But if we take a closer look at the hydrograph table data, this shows that this is not the case. So on this slide is a zoomed in view of the pre and post condition hydrographs. All right, and even a reduction in impervious cover should be reviewed to check the adjustment or change factors have been correctly applied to the appropriate storm calculations, and then the data examined instead of just the hydrographs to confirm that there are no exceedances. Now, you would similarly inspect the data for the other projected and all of the other current design storms to look for other instances where the post-development hydrograph exceeds the pre-development hydrograph. All right, and this is the example that you will find in the BMP manual in Chapter 5 that starts on page 41. Okay, so this example dispels the common misconception that the reduction of impervious surface will automatically meet the quantity control requirements. Okay, so moving on. Example 4, we're going to look at a scenario showing the groundwater recharge calculations. Okay, so we have a 2.5 acre wooded lot located in Somerset County, and we have the latitude and longitude of the site as well. The proposed development consists of a 1 acre office building, a ½ acre parking lot, and a ½ acre lawn area, plus 0.5 acres of existing woods to remain undisturbed. And we're going to design a stormwater management system to meet the stormwater management rules. And in this case, the stormwater present on site is HSGB. So we're going to assume that a small-scale infiltration basin is to be designed to meet the design and performance standards for the demonstration of the groundwater recharge requirement by infiltrating the increase in stormwater runoff from pre-construction to post-construction for the projected 2-year storm. And we are going to calculate the volume of runoff to be recharged. Okay, now, in Chapter 5 of the revised BMP manual, a design example uses these same site conditions shown here, but that design is laid out to manage stormwater close to the source of runoff, and the example includes in detail all the calculations. So if you want to see that detailed design, that's example 5-8, and it begins on page 71. But for this simple one, I'm going to skip the parts of the design calculation just to get ahead to groundwater recharge. All right, so I've included here in the table the NOAA rainfall depth, the future precipitation change factor for Somerset County, and the depth of precipitation for the projected 2-year design storm. Okay, with a depth of 3.93 inches, the projected 2-year design storm will produce an increase in runoff volume for the post-construction condition shown here in the bottom table on the right, which is 17,886 cubic feet. Okay, so to comply with the rule requirement, this is the target the design must achieve, provided it is designed in accordance with the BMP manual. Okay, the fifth example is sizing an MTD using the NRCS methodology. And if you recall, the rule amendments discontinued the use of the rational method and modified rational method for stormwater calculations. This example will walk you through what is now required. Okay, so we're going to calculate the peak flow rate for sizing an MTD, treating the water quality design storm from a 1/4 acre impervious motor vehicle surface. And the following parameters apply. So of course, the area is a 1/4 acre. We'll use a 5% slope. The CN value that we will use in our calculations is 98, as it is 100% impervious. Okay, our projected 2-year storm rainfall depth is 3.84 inches, and the hydraulically most distant point to the inlet of the MTD is 110 feet. So when using the NRCS methodology, you need to calculate the time of concentration. And for that, we follow the method that's covered in example 5-1 of chapter 5 in the BMP manual. And the example that is also covered here, you'll find on page 33 in the BMP manual. All right, it also uses the formula that was on slide 22. So as I stated earlier, we use P2 for the projected 2-year storm in the T sub C calculation for the water quality design storm. But there really won't be much difference here if we mistakenly used P2 from the current 2-year storm, given that the drainage area is only a 1/4 acre. Still, that difference comes into play for other projects with larger drainage areas, okay? But the next thing we do is we have to calculate the maximum sheet flow length using the formula for the McEwen-Speece limitation, which is found on page 24 of chapter 5 in the BMP manual, and that's equal to 909 feet. However, the maximum sheet flow length should not exceed either the McEwen-Speece limitation or 100 feet, whichever is shorter. So we're going to use 100 feet. And for our stated flow path length of 110 feet, that just leaves 10 feet of shallow concentrated flow. T sub C is calculated to be 0.8 minutes. Next, we also have to use the SCS standard dimensionless unit hydrograph with a shape factor of 484 to create the hydrograph. And this is also covered on page 27 of chapter 5 in the BMP manual. With all of this together, the modeling software then calculates the peak flow rate for the water quality design storm is equal to 0.77 cubic feet per second. The next step would be to determine the size of the MTD. And the selection of a model of a specific MTD listed on the department's MTD webpage is based on the maximum treatment flow rate, or MTFR, for a hydrodynamic type MTD, or the maximum allowable drainage area evaluation method and the MTFR evaluation method per the certification letter for the filtration type MTD. Okay, you will refer to chapter 9.5 for green infrastructure MTDs and chapter 11.3 for MTDs that are not certified as green infrastructure for this calculation. Okay, so that is really all I have for examples today, but please go through chapter 5 of the BMP manual for more details. Okay, and speaking of the BMP manual, let's move on to the updates that were made, plus those to the frequently asked questions and the model stormwater control ordinance. Okay, so the BMP manual chapters have been updated to align with the rule adoption and are listed here. Additionally, the frequently asked questions have been overhauled to address various issues. Okay, so this, just one moment. For those of you who like screenshots, this is from the updated BMP manual webpage. Everything that has been updated to this rule adoption has been marked as updated in the manner that you see shown here. And the FAQs have been expanded to address various issues, some of which I might have covered on earlier slides. The newest FAQs are at the bottom of the webpage, just above the blue footer. Look for the rule adoption date. Okay, and click on a question and it will expand to show the answer. Now, the updates to the stormwater control ordinance align with the rule adoption, and they can be downloaded in Word or PDF formats. On the left is a screenshot taken from the updated webpage of the items available to download. There's a clean copy, plus there's a strike-through version to illustrate where text has been removed. And with this, the new text also appears in red. Lastly, there's a simplified version. And this simplified version cites subchapter and section numbers from the stormwater management rules instead of the full text to reduce or eliminate the need for municipalities to revise their ordinance when the stormwater management rules are amended. A municipality has to comply with the applicable laws and procedures for the passage and adoption of ordinances pursuant to this simplified version. Municipalities must amend their municipal stormwater ordinance within 12 months of written notification by the department of the need for modification and update. That notification was sent on July 17th, 2023. Also, on the lower part of this slide is just a summary of the updates that were made to the SCO to match the rule adoption. We also updated any hyperlinks in the document and cleaned up the appearance. Okay. All right, so we're nearing the end of my part. All right, but we're not done, so do not leave. To summarize, the topics shown on the slide are the things that I've covered. We've had 2 definitions that were added to the rules, and after that, I covered the applicability to major development and discussed legacy provisions, which are those projects subject to the prior rules under certain conditions. There's also a change to the allowable calculation methods. After that, there was a bit longer discussion of the multipliers to be applied to modify the NOAA's published rainfall data and how those multipliers are used in the calculations for groundwater recharge and stormwater runoff quantity control. And I hope you found these brief examples to be helpful. Of course, there are more and detailed examples in Chapter 5 of the B&P manual. And in fact, if you go to page 33 in Chapter 5 of the manual, you'll find a table listing the various examples to help you find your place. I've also briefly touched on the other updates that we made to the B&P manual, the FAQs, and the Municipal Stormwater Control Ordinance. Okay, now here's our contact information, but we're not done just yet. So again, please don't leave. You have the slides. The video will be made available for you to download for reference. And please continue to periodically check our websites for updates to the B&P manual and other stormwater related material along with the training. Okay. At this point in time, if you are not seeing the July 2023 date at the bottom of the DEP's webpage for the B&P manual, then please be sure to refresh your browser. Okay, and now we are going to move on to our Q&A session.
Okay, Alvaro Gonzalez, sorry if I pronounce your name wrong. You can unmute yourself if you have questions.
Hi everybody. So it's not a question, it's more like a suggestion. If you go to Chapter 5 of the B&P manual, there is a table that provides the table 5.1 that provides the 24-hour rainfall for all the counties. But sometimes in my experience is that when you compare the county level 24-hour rainfall with the NOAA Atlas 14, what happens is that in some cases it's less and in some cases it's more. So it would be great to have just one source of rainfall.
Okay, thank you for the suggestion. Yeah, we have considered there was like a similar suggestion in the past, but we consider that the county average that was also provided by NRCS based on the rainfall data prior to 1999. So at this moment, we will still recognize the use of those averaged county rainfall data, but in the future, we may reconsider that whether that is accurate. Thank you.
All right, thanks.
Hi, this is Inti Athar from City of Newark. Is the minor development application can still use the rational method for estimating the pre and post surface runoff?
The stormwater management rule does not regulate minor development. So if your township allow the township ordinance allows it, we are not regulating that.
Thank you.
Mm-hmm. There are a couple of questions in the chat. Let me go through it. Tom asks what type of distribution is used for type CD. That is for the NRCS methodology that they have in addition to the typical type 2, type 3 rainfall distribution. For now, there is type C and D, and that distribution is for rainfall. The question, how did DEP come up the multipliers? It's based on Cornell University's studies. Those two studies are listed in the rule proposal. I can post the rule proposal here, so you can look up and see how the methodology being developed. Okay, I just post the rule proposal link. Vic asks, are the PPTN multiplier now required for BMP design submit for permit? If you have not submitted your permit application for DEP's land use permit listed in the rule, then yes, now it's subject to those multiplier when you utilize these the 210 100 years storm event to do the BMP design. Francis asked the question why the definition public roadway not including the roadway built by the developer, but then dedicated to the township. I think I already replied that the rationale is in the rule proposal, but I can send the link again, and it's a page, I believe, page 26. And for the question about the applicability of the rule amendment, you can go to the FAQ. We have prepared the scenario that about what and when, what situation and when the adopted rule apply to the project, whether it's in whether the project needs land use permit or whether the project only need a local approval. And Jay Sims asked will the IDF curves be updated for piping design? The IDF curve is being for the rational method. So for design of BMP, we will not use that anymore. But for the piping design, that's subject to the residential development standard, RSIs. I think you still need to follow the rule, the RSIs rule. And Mark Labor asks, can a township adopt an ordinance mandating that any disturbance over a quarter acre is a major development and that has to comply with 7:8? Yes, you can adopt ordinance that has smaller trigger of our threshold for disturbance, our impervious survey, and then you define that as a major development. Then that was subject to the stormwater control ordinance adopted by the township. And a question about the NOAA storm C and D change, or they would are still the same? Yeah, they are still the same. They are not changed. Jim asks, why provide two sets of rainfall hydrograph? Which one is the basis for design of BMP? When design on BMP, basically under NRCS method, is the rainfall depth and also the dimensionless unit hydrograph derived by the NRCS either SCS standard UDH or the Delmarva UDH. So I don't know the question regarding the rainfall hydrograph. And Val asks, 7 column A-4.3 and 4.4 require amended ACO to be approved by the county. I assume that is also true for ACO that are to be amended with those new regulations. Yes, definitely yes. If the township adopt a new stormwater control ordinance, it has to send to the county for approval. And today's presentation will be in PDF. We send out the a PDF file as the handout for today's presentation, and also this presentation is recorded, but we will not provide a PowerPoint file for this presentation. Vic asks, there are instances where public roadway are widened by developer. Will the additional payment area be considered public or private? I think in the proposal it has been laid out the situation whether the roadway is by the township, a public entity, and then the developer is required to do some off-site improvement. That would be considered as the part of the exemption. So you can check out the rule proposal. And for Tom Petzold, no, it's not required to submit hydrograph for the current and pre and post. Comparison of the hydrograph is just one of the three options that to demonstrate the development, the major development meeting comply with the stormwater runoff quantity standards. So if you if you use the reduction of the peak flow rate, then it's not the comparison of the hydrograph. And Joe Scupian asks, can the project's quantity control measures simply be designed to reduce the proposed condition projected peak flow rates to the allowable rates based upon either the existing condition NOAA or current peak is in a rule. So you have to meet both sets of the storm events, both the current and the projected. And I want to clarify that there's no minimum T sub C for the NRCS method, and for the rational method now we already removed that from the BMP menu. So I think that question is kind of moot. And that is the groundwater recharge required for PA1 redevelopment site. There's one urban redevelopment area that's been in the rule for a long time that has not been changed. So you can check the FAQ and also in the rule. For the question about the major development outside flood hazard area and approved by township, whether they need to and the construction need a substantial complete, whether they need approval. I think you may have to ask this question to the flood hazard area engineers. And for the my question, I think in the scenario, we already answered that question. If the township has not adopted the new SCO subject to the newly adopted rule, then the township may still review the project under the old ordinance. But the project, if they submit the application to the if the application needs a DP land use permit, but the application wasn't submitted prior to July 17, then it was subject to the new rule when they comes to the DEP for review. What is the deadline for the, there's a question about why is the deadline for municipal SCO to be updated? It's 1 year from the announcement we sent to the township. So we send the announcement to notify the township to update their SCO, and on the same day, the rule is amended, which is July 17. So up until July 17, 2024, they have to update their new SCO. For Stan's question, I think it's a little bit complicated. If you have this, the situation is welcome, you can discuss with us. And which project require DP review after a municipal review? The project need DP's permit is in the 7 Carne 1.6 applicability. So only those, so you can look up the rule. Yeah, for Joe's question, I'm whether we will update the NRCS C and D storm in light of the updated rainfall. For now, we have no plan, but we can look into this question because NRCS, as I have contact with the NRCS, they are not in any near future to update any rainfall distribution and any to the Atlas 14 volume 2, they are not going to update it. So the best shot we can have is the study from the Cornell that predict and adjust the rainfall data up to more recent weather stations data. We can take your suggestion and we will consider that when whether the resource or the data is available. For the Steve question, in the BMP menu, the McEwen speed limitation is only used for the post-construction condition. So I think I try to answer every question here. If you, okay, there's another question. Why was the year 2099 selected for the future projected stone date? Is there some significance to the time frame? It's based on the global warming model. There's been a methodology that the scientific field there has been used to predict the rainfall in the future based on the climate change or the green gas concentration. That would be the trend of those green gas concentration in the atmosphere. So it's always predicted like for the next 50 years or 49 years. So I think that's how the date was selected. It's just like to meet the most current trend in the estimating of the future rain. I think for the question about whether the SurveyMonkey we get that, if you submit it and you see that it says thank you for submission, and then your survey is received. But if you did not see the thank you page, that means maybe something wrong, and we probably did not receive your survey. I think it's pretty much every question I try to answer. So if you still have other questions, you may email us. There's the email address on the screen and also in the handout we provided.
Thanks, Changyi. Okay, so if there's no more questions, and then I think we can conclude the presentation for today. Thank you, everyone.